Hi there, I'm Noah, and this is my video for the first lab on charged tape. For an introduction into this lab, it's important to know that all objects contain protons and electrons, which give them some charge. Most objects are neutral or contain an equal number of both, but because electrons can be donated, meaning that you can either gain electrons or give them away, this can mean that some objects have a non-zero charge. This can be done to tape, giving it an imbalance of electrons to its protons, making it charged. And this will cause the tape to have different properties from its base. The goal of this lab is to find the excess charge on a charged tape to a factor of 10 by observing its properties and interactions with its surroundings. For the fundamentals to this lab, protons and electrons can generate an electric field, which acts on other objects. The equation for the electric field being the charge of the object over the distance from an observation point from the object squared times 1 over 4 pi epsilon 0 times the direction. And by multiplying this by the charge of an object at the observation point, you can find the force on the object at the observation point. And for the floating tape portion of the lab, Newton's second law is applied. Because there is no change in momentum, there is no net force on the object, meaning that the forces in the y direction will be balanced. Each tape strip has a mass of roughly 0.203 grams and a length of roughly 0.203 meters. To actually charge the tape, it is quickly removed from the base tape. Some expectations about how the tape will interact with its surroundings now that it's charged is that it should repel tapes made in a similar fashion. It should attract to neutral objects, such as one's hand or a book or a table. And if you have a negatively charged pen, should the tape be positively charged, they should attract. If the tape is negatively charged, it should repel. And if the tape is neutral, they should attract, but not to as significant a degree as if the tape were positive. As for the actual interactions, two similar tapes do in fact repel. When the tape is near a neutral object, it will attract, and when the tape is brought to a negatively charged pin, it attracts strongly, therefore the tape is positively charged. For the floating tape portion, we know that the tape itself is floating and it is not moving. Therefore, dp/dt in the y direction is equal to 0, and so the y forces balance out. The charged tape below tape B generates an electric field, which in turn causes a force on B in the positive y direction, while the gravitational force exerts in the negative y direction. Expanding upon this, we have F grav equals F electric, where F of grav is equal to the mass of the tape times the gravitational constant. And we have the electric force equaling the charge of the tape times the electric field generated by A. This can be simplified to mg is equal to q squared over 4 pi epsilon 0 times the magnitude of their distance squared, where d is the distance between the two tapes. And d was measured to be approximately 0.038 meters. Some assumptions before we get into the math and the coding is that tape is 1 gram per meter, the tape is 1 atom thick, the tape is secretly acting as a point, there are no other surrounding forces, both strips of tapes were the same length, and they have the same charge, and atoms have no distance between each other. Here's a photo of my GlowScript code. You can see the link to the code itself at the bottom. I highly recommend looking at it, as there are many comments actually going over the math and the code. As for the output, on the right you can see that the red arrow is the electric force being generated by the charged tape below the floating tape, and the white arrow is the gravitational force. The gravitational force on the tape is roughly 1.99 newtons. The charge on the tape is roughly 5.65 times 10 to the negative 7th coulombs. There's roughly 3.53 times 10 to the 13th number of deficient electrons. The approximate area of the tape strip is 0.0038 meters squared. The approximate number of atoms on the tape is 3.82 times 10 to the negative 16th. And the ratio of deficient electrons to atoms is 1 to 110,000, roughly. And the force is being measured in newtons, charge in coulombs, and area in meters squared. Some possible issues is that the tapes have unequal charges by being interacted with too much. The measurements were not exact, as only a standard ruler was used for the measurement. There could have been other forces acting on the floating tape from the surroundings. The room conditions could have not been ideal, and the tape could be old, with the adhesive being degraded. As for the what-ifs, if protons and electrons were swapped, we would generally not see a difference in interactions, or at least assumedly. However, instead of the electrons being donated or being obtained, the objects would gain or donate protons instead. And in the atom, The electrons would be in the nucleus, while the protons orbit at the greater distance. There could be some untold consequences, however, as protons are significantly larger than electrons. As for why, the tape needs to be handled carefully. Each time the charged tape is handled improperly, it inadvertently gains electrons from whatever it comes in contact with. This causes its charge to come closer to neutral, which is not what we want. We want to be able to observe the actual charge of the tape. And should it be handled too much, it would nullify our assumption that both tapes can share the same charge. That's all from me. Thanks for watching my video.